All right, we're going to be looking at transformations and algebraic representations. So a translation, we learned that, that's a movement, or we see it as a slide, like a slide up, down, left or right, and it can do both, up and left, or something like that. A movement or a slide of a figure along a straight line. So our example here, figure ABCD, it has slid up and right. And our rule, so for each of these points, so A and A prime, your XY will change depending on if we're going left or right. So if we go to the right, we're going to go positive, right? And if we go left, it would make it negative. And same thing for up and down. If it goes up, it's going to go positive, how many ever. And if it goes down, it's going to go negative, how many ever, to that Y value. Reflections, that's a transformation of a figure that flips across a line. So here is our rule. If it's going to reflect across the x-axis, your x value stays the same, but your y value becomes negative. So if it's a negative already, and a negative negative becomes a positive, but if it's positive, that would become a negative y value. If it flips across the y-axis, like our example here, this is flipped across the y-axis, your x value changes. If it was positive, it becomes negative, and if it was negative, it will change, like a negative negative will become positive. But your y value stays the same. It's not going up or down any, it's reflecting across that y-axis. All right, our next one, the rotations. That is a transformation where a figure is turned around a point. So our example here, figure ABCD, has rotated up. And so this one here is not a 90-degree turn, doesn't look like to me, and it went counterclockwise. So here's a couple of rules that may help you, and I just seen that I did not close my parenthesis there. All right, sorry about that. All right, 90-degree clockwise and 270 degrees counterclockwise, which I told you when we did these notes, you're going to end up in the same place, so they're going to follow the same rule. Your x value becomes your old y value, and your y value becomes the negative x value. And then for a 90-degree counterclockwise or a 270-degree clockwise, your x value becomes the negative y value, and your y value becomes the old x value. And as we do these, you're going to see how that works. All right, so here are some examples. You're going to use the rule that you know, that we just went over. All right, so it says a rectangle has vertices at 0, -2, 0, 3, 3, -2, and 3, 3. What are the coordinates of the vertices of the image after the translation? So our x is going to go x -6, and our y is going to go y -3. So we're going to start here. So 0 - 6 is -6. And then -2 - 3 is going to be -5. All right, so that's that one done. Next one, 0, 3. So 0 - 6, the x value -6, it's going to give me -6 again. And then 3 - 3 gives me 0. So that one's done. The next one, so my x value is 3. I need to subtract 6 from that. So 3 - 6 is -3. And then my -2 - 3 is going to be -5. And then that's that one. My last vertex, 3, 3. So 3 minus 6 is negative 3, and then 3 minus 3 is 0. And describe the translation. So right here, my x value, subtract 6, it's going to go 6 units across that x to the left. So we're going to go left. And then y minus 3, and so it's going to go 3 units down. All right, the next one I want you to do on your own here. So this is the first one I want you to do. Triangle ABC has vertices at, let's see, we've got A is negative 2, 6, B is 0, 5, and C is 3, negative 1. Find the vertices of triangle ABC after a reflection across the x-axis. All right, so before I have you work on this, I'm going to give you your rule in case you're on a different page and you can't see it across the x-axis. The rule states x, y becomes x negative y. All right, so you're going to find A prime, B prime, and C prime. All right, so we should have that by now. So negative 2, and the only thing that's going to change is that's going to become a negative 6. B prime, all right, my 0 stays the same, and that 5 becomes negative. All right, C prime, your x value stays the same, 3, and then we have a negative 1, so a negative 1 is a positive 1. How did you do on that? All right, the next one I want you to try. A triangle has vertices at J, negative 2, negative 4, K is at 1, 5, and L is at 2, 2. What are the coordinates of the vertices of the image after the triangle is rotated 90 degrees counterclockwise? So we have counterclockwise, right? And then I will write your rule for that, 90 degrees counterclockwise. Our rule is x, y becomes negative y, x. All right, so you've got your rule. What are your vertices of J prime, K prime, L prime? All right. So we should have, let's get this done. J prime. So a negative y, so a negative 4 is a positive 4, and then my x value is negative 2. Let's go to K. So my negative y is a negative 5, and my x value is 1. And then L prime. So we have a negative y, which is negative 2, and my x value stays the same. So if you were struggling with moving those rotations with just on the graph, these rules may help you, but you're going to have to make sure you're able to follow them. So I would look at these rules and see if they're helpful to you or not. And it's a good way to double check and make sure that your rotation was correct. All right. I want you to work on number 5. For 5 and 6, you're going to write a rule. So write the rule and describe the transformation. All right, so number 5, what's the rule? And then describe the transformation. All right, so we should have seen that our x value from MNOP, we went to the left 2. So our x went x minus 2. Y though, what did our y do? So here, let's go with P. It went 1, 2, 3, 4, 5 down. So we're going to go y minus 5. And then there was a translation of 2 units left and 5 units down. Okay, remember, this is just our slide one. We stood left and down. All right, now we look at 6. For 6, describe the rule. So write that algebraic rule, and then also tell me what the transformation does. All right, so we should have seen a rotation here, and we moved 2 quadrants, which tells me we have a rotation of 180 degrees. So I'm going to write that down here first, rotation of 180 degrees. So that's my describing the transformation. My rule, x, y, becomes, and our only difference here is negative x, negative y. All right. If you have any questions on any of this, please come to a meeting or email me, and have a great day.